and myself. But no Vlad or Nate, huh?
No.
Okay. All right. Well, we can get started. Um, uh, so, where did you guys? Since we don't have Vlad or those guys on, we can just talk about where we were with the whole gas discussion.
So I think where we ended off was um, every process has its own gas wallet, and then the only thing that you have to worry about is how you obtain gas up front and how a process passes its gas on to its continuations.
Okay. All right. So that was sort of the where that's kind of where we were when I jumped off. So not a lot changed.
No, I think when you jumped off, it was still ambiguous as to whether this was a Rev wallet or some other token wallet, as opposed to a gas wallet, and whether or not you were threading a conversion rate all the way through the computation as well.
I see.
But I think it's and I don't actually know if everyone came to the same conclusion or not, but I think it's more confusing to have a conversion rate threaded through the whole computation than to just convert up front and then carry gas through the computation, and maybe you have to resupply gas at some time later. But
I
it's
see. Okay.
like driving a car. You fill up, get at a particular gas price, drive for a little bit, and have to fill up again at possibly a
Yeah.
different gas price.
Yeah. Understood. Fair enough. Fair enough. And Kent, did you feel that was the conclusion?
Well, I agree with Mike on specifically that portion. Like, yeah, if we're gonna go the route of not necessarily sender always pays, then it makes sense to buy gas up front. Um, I I guess I wasn't fully convinced on whether we had to go to you know not necessarily sender always pays, but yeah.
Well, it's still in some sense a kind of cinder pays, right? Because the continuation may still be stuck unless there's a an injection of gas at the point of um, the output that unlocks the blocked input.
Yeah, I guess maybe I should say run to completion model. Yeah.
Oh, right. Yeah. No, I don't think run to completion can work. But yeah. Um, I see. I see. Yeah. Understood. Um, cool.
And the action item from that meeting was that Joe, since he had already been working a little bit on how gas gets propagated through continuations, he took away the responsibility of writing this up as a wiki thing for people to review. So we should be able to look forward to that at some point this week.
Oh, sweet. Sweet. That's really good. Great. Great. So then, were there any other outstanding items on just on that piece of the discussion?
I just have a question. It seems like you need a way in a contract to handle the out of gas exception in order for this to work. Is that possible?
Yeah. I mean, that's not an issue, right? The way exceptions are handled is they end up being, continuations, just like everything else, right? So you have a um, think about like if you had syntactic support for exceptions, like a try catch kind of thing, that would be turned into um, run this block of code, or if you hit or if you have another. So basically, you have a sum, right? It's a select construction in Rolang, and the block of code is effectively racing against the exception. Does that make sense?
Yeah, I guess it was just a question of exceptions and generating a out of gas exception and how that.
So the generation of that. But see, the thing is that if you're sitting there blocked on an input, it's not necessarily the case that you're out of gas because the sender could supply gas. You're only out of gas if you what are the conditions under which you're out of gas?
So if I understand like the not run to completion model correctly, like you don't actually get out of gas errors anymore, which might sound nice, but I guess I'm just worried about things related to like atomicity. And I mean, Kyle said he's gonna think of a solution, I think, but
what's the atomicity condition here? For us, atomicity means you either have a comma event or you don't.
Well, I mean stuff like can you pause in the middle of let's say you have a balance transfer. Well, maybe I should use a different example, but essentially I'm thinking of places in which it would be kind of bad to stop in the middle, right? Maybe it's like
understood, but there's no middle for Rolang code is kind of what I'm trying to say. There's very little that's straight line code.
So
the locking mechanism is the COM event.
So I guess are we saying like for statements are going to be atomic in the sense that you either run them to the next one or you stop? Is that what it means?
Well, just think about it this way. It's not that you run them to the next one. It's like if you can get through a particular for comprehension, a blocked input, right? That means that the output and the input have hit each other and the data has transferred. So that operation is atomic. And then the release of the continuation, well, what's in the continuation? Basically, it's either an output or an input. So there's no other stopping in the middle. If you're blocked on an input, you're blocked on an input. If you're sending an output, there's no blocking that, and there's nothing that you could do that you wouldn't want to be stopped in the middle. The only thing left remainder is if in the output you do some intermediate computation, right? Like add two numbers together, but those aren't going to stop in the middle.
I see. So effectively, like if you can't stop in the middle of an intermediate computation.
Yeah, you can't.
Question, Greg. So
yeah.
if I'm the sender and I'm sending something in and I want to know everything didn't go through, but it could be a couple reasons. Either it's blocked for input or blocked for some other, let's call it legitimate reason or just normal reason, and then it's blocked because of an out of gas thing. Meaning, if I just send it some more gas, it'll work. Whereas the other reason, it's just needs to wait for something else to happen. How would I know that either of those conditions are true?
Okay, so in the case of a needs to wait for something else to happen, the only way that can occur is if you've got a join statement.
Okay.
So if you have a join, then you know that you're you're waiting on another input. If you're in the case of you didn't send enough gas, then the send will fail.
Hmm. Okay. And so then any interpreter, or meaning any user feedback, would just use that explanation that you just gave to notify the sender
Yeah,
however
exactly.
they would want. Yeah. So like
Yeah.
what the example being Etherscan will tell you this process ran out of gas. And that's how
Yeah.
they would
Yeah.
determine
So,
that.
I mean, effectively, what you're really asking about is a kind of synchronous handshake where, the output doesn't happen unless there's a corresponding response from the input.
Right.
So, so, so you can do that kind of at a higher level where, I mean, what you do is you literally build a handshake protocol on top of outputs that where you want that to happen. So the handshake protocol is, I send the thing, I get an acknowledgement, and then I can release some other computation based upon that acknowledgement.
So Kent, was that getting at your question about sort of the gas errors and not having them, that kind of thing?
Well, so I guess what I'm confused about is you can have a parse statement, or sorry, like a bunch of parred outputs, for example,
Mhm.
in the continuation, right? And so
Yes.
if you run, let's say, just one of the outputs that are in this par, like I guess what I'm getting at is you sort of need to know like what amount of gas will cost, or throw or have these out of gas exceptions, right? I mean, is that kind of the model we're running under?
So let's go through that. Let's say that the continuation. So we have a for comprehension. The for comprehension receives some amount of gas, and the continuation is a body of pars. Then under the model that we talked about, they all a par of outputs, right? So that's the body is a par of outputs. Then they all receive kind of some distribution of the gas that was received by the continuation. Now, they're not going to have. Okay, it is possible that if they don't receive enough storage pool, then they can't fire. So I guess that is an honest to God out of gas exception, although our model of gas is a little different. Right? Does that make sense?
Sorry, Greg, can that actually happen? Because the continuation before, like, while it's still guarded, still needs to be stored. So the storage should have had to be paid for up front, right? Like when you deploy an entire row-length term, you need to store the whole term the entire time, even if it's not.
Right.
Yeah.
Yeah. But notice that when you do the output, you're storing it somewhere else. You're storing it at a different location.
Sure, but
so
that shouldn't cost more, should it?
Yeah, of course, because you may be storing it, in a literally a different location. So that should cost you something. You're transferring this storage, this data packet, to some other place.
But that sounds like an implementation detail that, like, if we, how can we decide up front how much that should cost when it's an implementation detail of what it?
No, but it really isn't an implementation detail. It may be that when you do the output, you don't have the data that until you've unlocked the input. So consider the following for y from x, and then you're going to output y you're going to copy y on two different channels.
Okay,
so
gotcha.
then,
Yeah, I see what you're saying. Yep, understood.
Yeah, so cool. So in that case, I guess it is possible for the storage fee for copying Y to two different channels has not been paid. So that would be an out of gas error. So we would have to handle that exception. If there's if there's an insufficient storage fee, then we would have to generate an out of gas error in that case.
Although, could we maybe optimize this in some way? Like if Y is being sent over X, Y should have had to pay for its own storage to have been sent over X initially. So that's fine. And then as long as you under the hood are just using pointers, then there's not really the copy operation doesn't actually happen. Is what I'm getting at. So as long as Y was
but what if those channels are really they're in different namespaces with a different sort of storage model.
Well, yeah, I guess cross namespace stuff is potentially tricky. But that was sort of out of the scope of our original discussion.
Oh, okay. No, I mean, I was really thinking that this at least goes. I mean, even if we just have name groups, if it goes to a separate group, that group is going to be, there may be a different storage cost there.
Yeah. Okay.
So actually, that was worthwhile, Kent. So it's not quite all or. How do I say this? You know for a fact that the COM event that would be associated with the outputs in the continuation is all or nothing. But you don't necessarily know that those messages were delivered. Is that run to completion? I think it's just a fundamentally different compute model. But I mean, I don't know.
Yeah, that sounds different indeed. And I guess I'm just worried about the complexities there. I mean, it seems like we have a sort of run to completion model, but not really. And now if you're a contract writer, you might deploy something and then you might send outputs to it, and then you'll get an out of gas error, but then it wasn't actually your fault. I mean, I guess that's not the biggest issue.
I hear you.
I could see it totally working if you just hash out the details and whatnot, but it does seem to be more complicated. I guess I never really understood why the run to completion model just simply doesn't work. Does that make sense?
Thanks. You too. Well, it doesn't work because we have these long-running transactions, right? I mean, we can be blocked on input. So how do you run to completion?
Yeah, that's fine. You're just blocked on input until everything comes together.
I just let them know they're supposed to come down.
So, Greg, just to give a little context to it, completion was always defined as meaning no further COM events can happen. Right, so you par in some new code, you do all the available COM events, and then once there are no more, you're done. That's it. That counts as completed for the deployment of that code. But then it still sits in the state and can still be interacted with future deployments.
Well, I mean, in that case, it feels like this is run to completion. I guess I don't understand. I mean, that definition matches what we've come up with.
Oh, so I think the big difference is that in this model, you don't have wallets attached to for comprehensions, right?
Oh yeah, but how do you?
And so
hang on a second, Kenny, we're here. I just don't know where here is. We're at the Napfstrasse 10.
Yep, got it. I'm going to come down and get you.
Okay, sounds good. So you have to have wallets attached to for comprehensions because, okay. Let's consider the alternative. What happens if you don't? How do you launch additional code?
I guess that's what I meant by sender always pays plus run to completion. Like the last person who, or like the I guess whatever completes before is the one that pays forever down, so to speak.
Or I guess phrased another way, deployer always pays, right? When
That doesn't feel really fair. Yeah, that doesn't feel really fair, does it? Right?
Yeah, I agree. It's kind of a trade-off for simplicity. It's it is how Ethereum currently works, though, right? And I guess another thing is that, you know, I mean, I think I've mentioned this before too, but you can always structure it such that I guess the person who is sending doesn't have to pay in the end, or, you know, with some kind of refunding model, you can have off-chain triggers. I feel like there are lots of ways to handle, or I guess handle costs that can go around this model, that I feel are simpler than trying to, I guess, include details of how to adjust these payments inside the protocol. And I'm also hoping at the same time that these costs are like relatively cheap. So, you know, hopefully, I guess maybe this is kind of, you know, about vision, but, you know, like, are we imagining our chain to have, you know, like $20 transactions, or, you know, or are we, I guess, I guess my point is, I'm hoping to keep, like, gas costs are, I guess they don't really add to the platform, if that makes sense, right? Like, the less we have to care about, you know, gas related costs, I think it's better, because they don't actually do any transactions, if that makes sense, right? Like, if like if the network overall as a result gets I guess a less of a hit in overall, then I feel like the trade-off is worth it. But yeah, does that make sense?
I think we lost Greg at some point.
Yeah, I
don't
guess
see him
so.
on the participants list anymore.
He'll be right back, guys. He just had to use the restroom, but then he's going to get connected right up. So you might have to repeat some of that, Kent.
Sure.
Sorry.
Ow.
Welcome back.
Sorry about that.
Yeah, no worries.
And we're trying to eliminate gas costs. We're trying to make this free.
Yeah.
But
You just have to kill all the DOS attackers.
Yeah, right. When you have communicating processes that are long-lived and, you know, are providing services in a collective manner, you know, the gas needs to be paid collectively, which
well, I think that was. Oh man, the echo is just killing me. Let's see, what can I do?
I think Kenny should mute. Standing next to Kenny.
If you mute, can yeah. Are you muted now? Oh, that's weird. Yeah. Oh, it's coming in through your headphones. Oh, no, it shouldn't be, because you're muted. Oh yeah, now now I have nothing. Yeah. Yeah. So that's weird. Okay. All right. So sorry about that. So I mean, in both models, where the sender is going to supply some amount of gas, right? And so let's consider the case where we have contract C, parametric in ports X1 through Xn, and the body is in a par where where there's a four comprehension listening on X1 in parallel with a four comprehension listening on X2, et cetera, out to Xn. Okay, so now the deployer of the contract, I'm sorry, the deployer of the contract instance. I want to make a distinction between deploying the contract, which just puts a listener up there waiting to launch that body, versus someone who deploys an instance which sends some gas to the name C, which launches that par of four comprehensions. And when it does send to the name C, it's also sending a bunch of names, X1 through Xn. Okay, so there's an initial amount of gas that's paid just to launch those four comprehensions, right? And then those four comprehensions are all stuck. They're just blocked, waiting. And now a sender to say Xi is going to deploy, is going to send some gas and unlock one of those continuations. But should that sender be responsible for the other continuations? Should the party that sent gas to C be responsible for the other continuations? How does that work? But if each sender is supplying gas to unlock the corresponding continuation, then the collective, in some sense, is paying for the collective waiting. Does that make sense?
Yeah, I totally see the model. I guess it is, I guess, in terms of pure gas cost calculations, just more complicated than sender pays was.
And that description just now was totally commensurate with deployer pays and deploys go to completion, right? Because the person who puts the contract on the state pays for the storage of the contract. The person who invokes the contract would pay for the deployment of C bang whatever X is, and then the invokers of those fours would deploy, XN bang whatever.
Well,
right.
Technically, it adds like however many adds as number of joins, right? Like, so in the sender page,
there's no join in the example I was giving. They're all parred. Just you have a continuation P1 waiting on X1, a continuation P2 waiting on X2, and they're all in par.
I see. Okay. Well, I guess. Oh yeah. Then yeah. This is Mike said. So I guess. Did you hear earlier when I said I want to, I guess, lower the number of gas computations for the overall platform?
Sure, that makes a lot of sense. But here's the problem. So sorry. So suppose that the you don't have a wallet associated with continuation PI. And now let's say that the wallet PI is a bunch of pars of star X or star Z for some Zs that have been passed into the contract. Then who launches those? Who pays for those?
Yeah, I understand. Like, the sender might not be able to pay
but and like, you can just, I guess, were you not convinced by the off-chain trigger idea?
No, I really don't like off-chain triggers.
I guess, can you clarify why?
So what's the transaction model here?
So we're, I guess, assuming the sender always pays plus run till you can. Maybe that's the better way to put it.
So who pays for the star Zs?
Well, so I don't. I mean, it's the person who's completing. Oh, the star Zs. That's the person who triggered the, or the person who allowed the output to match with a 4, and then that 4, whatever got through that 4, then.
Well, come on. The person that allowed that was the collection of validators. So so just to be super clear, let's put these in a race condition. Okay, so we have 2 4s racing, and one of which has these star Zs that are going to be released if the 4 matches. So now the decision about which of these races wins is made by the validators. It's not made by any one of the senders, right? So
Yeah, I agree there. Yep.
okay, so then there's a single sender. There's 2 4s. The validators agree that it's the one that releases the star Zs. Who pays for the star Zs to be launched?
I mean, I guess it's always the sender. So, like the sender of the output, is that what you're asking?
Well, that's what I'm asking in the model. So I guess what I would say is this sender. There has to be something that apportions the sender's gas out to the pars of the star Zs.
Yeah, and so, I mean, I think we're a bit off from the off-chain trigger idea here, though, because in the off-chain trigger idea, essentially you structure your contract such that you would get input from one party, and then so you have a join, and then you get input, the public data or whatever that you need to get into, I guess, one part of the join, and then when you confirm that you receive that, then you trigger off-chain another, I guess it goes, or you're looking at this join from off the chain, and then you see that some data has come in, and so you send in an output to that join, and then the output completes. But then the person
that's what I'm saying. That's what I'm saying.
Okay.
So you have so the transactional model is kind of, it is possible for someone to starve things, like really get things stuck in the middle, right? And now you have COM events that don't complete because an attacker says, yeah, I'm not going to pay.
Well, but why would you attack your own contract?
No. Yes. So, someone is attacking the contract, right?
Well, so
they can launch a bunch of these instances which are now stuck in limbo with no payment, which puts.
Like, you always pay for the deploy, and you always pay for the transaction you send until you get stuck. So there's no, I guess, there's no way to, I guess, cheat this system. At least, it's the same as Ethereum currently, right? You can't send a transaction that costs nothing. But I guess my point is that when I say you structure it such that,
yeah, I really hate this the deployment language, because so what do we call it? I want to distinguish between when we deploy contract code versus when we deploy contract body.
But I don't think that is a distinction that needs to be made, because when you deploy, all you're doing is taking some piece of code and adding it in par with the existing code, and then stuff can happen. So that you could par in a contract definition, or you could par in an output, which then triggers a contract definition, but both are just parring in some code.
Yeah, but if I want to debug, I really want to know which thing I deployed, right? Did I launch? Did I just store some code at an address, or did I start running the code? Because I mean that really matters. Because if I started running the code,
those two is whether or not you triggered a COM event. Right? If you didn't trigger a COM event, then all that happened is what you deployed got stored. And if you did trigger a COM event, then the ensuing computation happened.
But that's not true, right? Because there's a COM event that sets up. There's a COM event with the contract deployment mechanism. I'm now registering this contract with the system. That registration is a COM event in terms of a system contract.
I see. So why does it have to be that way?
Because we don't want to have some other specialized mechanism that's not Rolang that handles, registering contracts with the system.
Why can't I literally just have existing code bar new code, just like the actual parallel thing that's in Rolang?
I mean, you can do that. You can do that. The issue is, how do I then associate, contract names with code, right? I want to be able to set up a listener that will, for a particular contract name that, receives launch the body.
Because you can do at quote some name end quote.
Yeah, I think that's a terrible idea, right? So contract should be given an ID, right? And there's a human readable name, and so that's so then you'd want to do some kind of lookup independent of that. But that's neither here nor there. The point is, I want to be able to distinguish those events. One is, I'm not running the code. I'm just registering the code with the name. I mean, in practical, day-to-day working, I need to know, am I running this code or am I registering this code with this name? That's a real distinction. It's just like, am I running this method, or am I, okay, hang on a second. Okay, I can't process both at the same time. Sorry. So I see that Kent is describing something. So
yeah.
So,
okay. Sorry, I was gonna wait until you finished. But
okay. All right. Cool. All I'm saying is, there's a difference between the implementation of these events versus the fact that the events are significantly different in terms of use. Does that make sense?
Sure. And I'm saying that so taking your example of defining a method versus invoking a method, right? That if you want, in Rolang, if you write a contract definition, like using the contract keyword, that is defining something that could be called in the future.
Exactly. But the way that happens in terms of executing that is that there's a listener, which is, set up to register. There's a listener for contract behavior, which sets up the registration of the contract name to the body of the contract, which is literally listening on the name and launching the body.
I just guess I don't see the reason to add that extra piece of complication.
No, that's not an extra piece of complication. That's literally the semantics.
Well, so when you say set up a listener, you mean that we now have an entry in the tuple space under that name, so that
That's right.
Yeah.
Exactly.
Okay. So I guess I'm still missing what your point is.
So that is different from sending to the name that will launch the body.
Yes, and the
Okay.
way the user knows the difference is the contract keyword, right? When you use that keyword, you're saying this is some definition that I am making.
Understood. So the language of deploying a contract is not precise because we don't say whether deploy means launching the contract body, i.e. sending to the listener on the contract name, or registering the contract listener. Those are two different. Those are two different things. They in common parlance, deployment is used for both. So it becomes important to have distinction because they are real distinctions. They're material distinctions.
So would you be happy with nomenclature that both you agree that both operations can be just parring in some piece of code, whether you par in a contract definition or par in an output that matches an existing contract definition.
Which is the same in Java, right? When you add a method, you're adding, it's still object computation, but just on the class object as opposed to the instance. So yes, in principle, these operations are the same, but materially, in terms of the expected behavior, we are registering the contract in the tuple space, the contract body with the name in the tuple space in one case, and we're launching the contract body in the other case. So what language are you proposing?
Well, could we say I don't know, could we make it as clear as deploy contract definition and deploy output, like deploy a bang, like a term that has a bang in it, like bang deploy versus contract deploy, just
bang deploy, bang could be used on any arbitrary code, but that doesn't tell us that it was associated with the contract body, right? If we want to do any sort of provenance or any sort of debugging, we want to know that particular peeling off of the bang was associated with that contract name. It's an instance of that contract. So I would call that, so there's contract definition deployment, which I would normally think of as contract deployment. And then there's contract instance deployment. So we actually launch an instance of the contract body.
Okay, sure. We can have this linguistic definition.
But it's actually a material definition, right? There's different, they're not bisimilar.
Yeah, they're not bisimilar, but they're two cases of the same operation.
Sure, I'm using the operation to do one thing in one case and the operation to do another thing in another case, just like in Java, right? I'm using the same operations to implement adding a method to a class as I do to run a method, right? I'm using the whole family of operations that are associated with the JVM, but I use them for different things at different times.
Sure. Okay. So now the model that we've been talking about is, so the phrase I was using was deployer always pays, but I guess that's not super specific if you're thinking of contract deployment versus contract instance deployment.
Right. Yeah.
So what I mean when I say that is the most recent deployment to have occurred, the person who did that pays. And there's a sequence of deployments from the perspective of validators, right? That's part of their job, is to sequence these things. So if someone does a contract deployment, they are going to have to pay for the storage of that contract in the tuple space, and probably that's it. They probably won't immediately trigger any COM events. And then later, someone will do contract instance deployment, and that person will have to pay for calling the contract and any subsequent things that happen as a result of doing that call.
Any subsequent things?
Yeah. So if
so in Nash's example, so so let's say that Alice learns about a search service, and she sends a call to the search service. If the search service also does analytics, Alice pays for the analytics.
Correct. But to Kent's point, you can, within this model, prevent Alice from paying for the analytics in the following way. You have, when the search happens, you don't actually trigger a new computation. You trigger a lonely output or input, something that isn't going to trigger a new COM event. Have that sit in the state. Yes, Alice has to pay for the storage of that new thing in the state, but that's probably fine. That's just part of the usage of the search thing. And then off-chain, the people who are watching their search service being used see, okay, we've built up a whole bunch of these lonely outputs or inputs, these things that haven't triggered COM events that represent our analytics. Now that we have enough on there, let's go ahead and do some analytics on these things. So then they would go and do instance deployment to match all of those, and they would pay for that.
How do we implement the monitoring mechanism?
So that's the off-chain trigger, right? And
no, but how do we implement? So what I'm saying is this additional monitoring mechanism could be broken in any number of ways, and so now these COM events no longer have atomic transactional semantics.
I agree. So it's no longer real time, right? Or I mean, it could be sort of real time, but there's no guarantee. And I think but I think so. For the example that we're talking about, though, or for most public data feeds, I think it's fine because either if you really need the result, then what you can do is compute it for yourself, right?
Oh no, because now you're spending money on something that you were expecting someone else to be spending money on.
Oh no. Because you're spending money in the sense that you're doing the computation on chain.
Correct. Yeah. So now the transactional model is completely broken, right? So we no longer have atomic transactions. They can be delayed ad nauseam, forever potentially, and otherwise, if they're not delayed, then the party that wanted to use the global computer is now running a local computation.
Well, but
so that's a very, very different computational model.
That it's only when you're, I guess, when you really need the result like immediately, right? Like otherwise, like it's in a sense cheaper for both ends, right? And so you either just wait until the service helps you out, or you can do it yourself. Worst case, if you need it like immediately.
So no, but the biggest problem is that the monitoring mechanism is now completely outside of the whole semantic framework. Now we just have this extra ad hoc monitoring mechanism that's just hanging out there. And I mean, yeah, that's kind of the opposite of what we're trying to do. So like anyone can come along and provide a monitoring semantics, and how does that play with everying else?
Well, great. You can't stop people from doing that anyways, right? Like that's the thing about off-chain.
No, but I guess my point is that as long as it's off-chain and it doesn't impact our transactional model, we don't care. But if we're now wedding our transactional model to this off-chain behavior, we do care.
I'm not sure what you mean by wedding the off-chain with the transactional model, because in my
Because the
example,
transactions can't go forward. They can't go forward, right?
well, yeah,
They
because
can't go forward.
they're input blocked on input that they don't have yet. That input being it's time to run analytics. Like, you don't want to run analytics literally every time someone uses your search thing. That, like, one new data point isn't going to do anything for you.
No, but that's really up to the programmer, right? The programmer should be in charge of that, not some ad hoc mechanism that the programmer doesn't know about. Because
well, the programmer is probably the person who wrote that ad hoc mechanism, right? We're talking about a service provider who's writing a whole D app, right? Part of it's on chain, part of it is off chain.
No, but this, this is what I'm arguing. Is like now when you look at the code, you can't see part of the transactional mechanism. What I'm trying to do is to build a system where when you look at the code, you see everything.
Yeah, so I guess in this system, you see the fact that, if data comes in here, it's just going to pause. And you need another piece of data before you keep going. And I think, for expensive computations, I mean, it sounds like a decent trade-off, right? Because if it's a cheap computation, then you can just have a tender pace, and that would.
I mean, if I've understood your model, you're like breaking the fundamental atomicity of the COM event.
Well, no, the COM event still exists, right? Like I have not changed.
It's there, but it's there, but it's not done, right? That's the thing I'm trying to say.
Yeah, but you can have not done. I guess forest right now, right? Like you can write, a large join and never fulfill it. I mean, I guess.
No, but no. The point is that you're going to compile every atomic for into a join, and that is what's breaking the model, right? What we want is to have something that is rock bottom, and the idea is that the rock bottom is the atomic for. And then you compile the join down to the atomic for. Now you said, no, that's not the rock bottom. It's join semantics is the rock bottom. So.
Oh, no. I'm not changing the semantics at all, right? Like it's it's the same thing. You compile joins down to atomic forms, right? As you said.
So then then I don't understand how the mechanism works. We have 4 minutes until the dev stand up. But so explain to me, like let's pick a let's write down a piece of code. Okay, so we have contract C. It's parametric in X1 through Xn, and it's how about just X1 and X2, right?
So
and
chat?
Hang on a second.
Or is it better that I screen share or?
Hang on a second.
Yeah, okay.
Okay, now I can see the chat.
So
I ignore the above.
Yeah. And so we have a join, and the idea is that so P is like the analytics in this model, right? And so someone sends in an input on Y1, and sorry, I have to write from because for some reason Zoom doesn't parse the left arrow. But anyways, from Y1, or it sends some public data on Y1, and this is the person who's doing like the search, so to speak. And then so Y1 does not complete the join, right? Because it still needs input from Y2. And so whenever someone sends something on Y1, the service provider sends a piece of data on Y2, and then the analytics runs. Does that make sense?
That's I understand, but that's not I mean, you can write that kind of application right now. The question is, what if the application programmer wrote for themselves a single wait for the search term from Y1, and then the analytics is all inside P. So as I understand your proposal, you're going to transform that code into a join.
Well, so no, as you said,
Okay,
before,
then
you can already do this now, right? There's nothing special about. I'm not proposing a language change, a framework change. I'm just saying, we can keep our current model with sender pays and still have public data feeds, right? That's
no, but I guess what I'm trying to say is that it doesn't solve the case when they put the analytics inside P. You're saying if you don't want to pay for it, then so in the sender pays model, if the analytics is inside P, who pays to launch the PAR, which is the analytics?
So if the contract writer provided the service included their analytics to trigger at the same time as the service itself runs, then the person using the service would have to pay for the analytics. That is true. And I think what would happen is the users would realize that the search engine is really expensive. Maybe they don't understand why, but it's really, really expensive, and they would stop using it, right? Like it doesn't solve the case that you're proposing, but it does allow for an alternative that provides the same behavior as a thing still happens, like the analytics still happen without the user paying for them, is the only argument.
Okay, now I understand your argument. So yeah, so thank you. That's greatly clarifying. So basically what you're saying is you could restructure the code in such a way that in the sender always pays model, you can restructure the code not in an automated fashion, but contract writers have the option to restructure the code in such a way that an additional input is required to launch the analytics, and that's paid for by someone else.
Yes.
Yeah.
Okay.
And I also want to add
Okay.
that if you lose the race, or if it's the opposite case, then if the sender didn't put enough gas into their send, then the analytics wouldn't complete, and yeah, they wouldn't ever. So I guess there's no worst case scenario in which the sender of the data for some reason pays more than they wanted to or like they get a surprise and they have to pay a huge bill.
Okay, I mean, I think I see the proposal. I want to continue, but we have this the dev stand up on the other channel, so got to jump over to there.
Yep. See.
Awesome. Well, yeah. Okay. Ciao, guys. Thanks, Christian.
No problem. See you later.